Okay, everybody, this is Mr. Bells again. How we doing? Um, this is section 8.5. This is it. This is the last one that you have to do if you've been following through the things. Remember again that in chapter 10 there were two things that I emailed, two separate things on law of sines and law of cosines. That's a worksheet that isn't in the Big Ideas Math online section that we still need to do. But this is the bottom one or the last one of the Big Idea stuff. So this is talking about something called a recursive rule with sequences. In a recursive rule, I'll just give you a basic thing here. A recursive rule says that if I know where we're at right now, and I tell you how to get to the next place, then you can generate that that statement. Okay, so I give you a starting point, and then I tell you what do you do to it next to get the following terms, and then you keep repeating that same next step to every single term after that. Okay, so recursive blank tells how the nth term of a sequence is related to one or more preceding terms. We're going to say that that is called a recursive equation, and you can just fill that one in on that one. And I'm going to talk to you a little bit about these things down here. So, sorry, equation for that one. Recursive rule is a equation that tells you the first term and how to get to the next, or using some things to get all the rest of them. An explicit rule tells you that you can get to the nth term value just by plugging stuff in. An arithmetic sequence means that it's a sequence that goes up, let's go 3, 7, 11, 15, goes up by addition every time. A geometric sequence, sorry, that's addition or subtraction, goes up by multiplication or division. And you guys know that addition and subtraction are the same things. It's just adding a negative number, and multiplication and division are the same things. Division by 7 is the same thing as multiplying by 1/7. So a recursive equation is an equation that you can use to generate the recursive formula. The rule tells you how to get from one term to the next in an equation. Gives you that stuff. So you can fill those ones in based on it. And let's start the meat of some of these problems. So this first one right here says write the first 6 terms of the sequence. So this is, again, I think it's going to be pretty easy stuff, but the notation's a little freaky for people sometimes the first time they see it. So I'm going to kind of point this out. So it'll say to you, again, what the first term is. So a sub 1 equals 1, and we can do that easily. We can just plug the 1 into there. But then it says a sub n, where it could be the second term or the third term or the fourth term or the fifth term or the sixth term, whatever nth term it is equal to, and this is still a little counter, right? This is telling you which one of the terms it is. So if we want to know a sub 2, or let n equal 2, then we need to know the previous term. So a sub n minus 1 simply means count back 1 from that term to get the other one. So think of it as previous term plus 3. Okay, so the second term is equal to the previous term plus 3. So that would be 4. And the third term is equal to the previous term plus 3, so that would be 7. And the fourth term is equal to the previous term plus 3, that would be 10. And so on down the line. See how that works out like that? Okay, so this next one says that a sub 1 equals 2, so we plug a little 2 in there. And a sub n, so then the next term is equal to the previous term squared plus 1. So I square this one, which is 4, plus 1, which is 5. And then I take the previous term, 5, and I square it, which is 25 plus 1, which is 26. And then I take the previous term and I square it, and I'll be honest, I need my calculator for that one. 26 times 26. We get 676 plus 1 is 677. And those are going to get bigger too, but you can use your calculators to be able to do that. So you'll notice now that my sequence, this one right here, isn't arithmetic and it isn't geometric. I can't produce this through addition or subtraction, and I can't produce it through multiplication or division. But I can generate it recursively using the value of the previous term. So these other terms are being generated based on multiple things. Okay, so these next two now show us, it says write a recursive rule for it. So the recursive rule always has two parts, and the two parts are what A1 equals and what AN equals. So A1's pretty easy, you just have to look at it. The first term is 21. And then A sub n states, how do I get to that next term? So you can see up here, 21 goes to 14, goes to 7, goes to 0, goes to negative 7. This one's pretty easy to get. You simply take the previous term, whatever the previous term was. And again, I want to make sure this little minus 1 is down here in the subscript spot. It's just telling you to count one less term's value than what was before. It's not subtracting 1 from a number. I don't do 21 minus 20. It means I'm going up or down, whatever this thing says, from the term number that you're at. Okay? So A sub n minus 1, and then I'm going to go minus 7. And that's what I have to do. So to pick any term that I want, say the fourth term right here, fourth term is 0. Then the fourth term says I need to take the third term's value, A sub 4 minus 1, so A sub 3, right? Which is 7, right there. Then subtract 7 to get that one, and it's 0. Okay, so that's how recursive works. And if you can do that there, then you can do that one down here too, based on the way this expression is going. I believe in you. Okay. So here we go. This one says write a recursive rule for the sequence shown in the graph. So f of 1, well, you just have to look at the chart. Where's f of 1? Well, here's a 2, here's a 0, here's a 4. F of 1 equals 1, right? And then how do I get to the next one? So 1 gives me 1, 2 gives me 2, 3 gives me 3. And if I'm trying to write a recursive rule for it, f of n equals f of n minus 1 plus 1. That's what the recursive rule would give you. So again, f of 1 equals 1, and then f of n equals whatever happened before it, plus 1. Okay? And based on what we've just talked about now, here's another one of these problems. I try to put a lot of these in because I think it's good for you guys to be able to look at stuff that's done wrong and be able to explain why it's wrong. So here's another one of those problems, and hopefully that helps. I'll pick the right ones off of here. And next section, here we go. This one says write a recursive rule for a sub n equals 3 plus 4n. Okay, so this, and I know it's subtle, but this is an explicit formula, because an explicit one is, we've used these for the last 4 sections. An explicit formula is one where if I want to know the 100th term, I simply stick 100 into the problem, and you can see that the 100th term is going to be 403. Okay? But it says, please write a recursive. And again, recursive needs 2 parts. So I need to know what a sub 1 equals. And how do I get the first term? Well, I just simply plug 1 in. So 4 times 1 is 4, plus 3 is 7. So a sub 1 equals 7. And a sub n equals, and then a sub n minus 1. And let's plug 2 in. So 2 times 4 is 8, plus 3 is 11. So I would get 7, I would get 11, I'm going to get 15. So you can see that I'm simply adding 4 each time to whatever was there beforehand. Okay, this is a recursive. It's got 2 parts. Tells you where to start, tells you how to go to the next term. This formula itself really kind of stinks if I need to know, say, say I need to know a sub 99. So in order to get a sub 99, I would have to know, according to this, I would have to know what the 98th term is. I don't know the 98th term. And to find out the 98th term, I need to know the 97th term. To know the 97th term, I need to find out the 96th term, and so on down the line. And I only know the first term. So recursives really aren't as beneficial if we have an explicit, because it can get this there. But we can generate sequences that we can't generate this way through a recursive scenario. And there's other ones that we haven't done on here. Let me show you one of those. Let's say that I had this. Here's a brand new recursive formula. And I could say that a sub 1 equals 4 and a sub 2 equals, where I'm going to give you two of these things, 4 and then 11. I'm going to start them that way. And then a sub n equals 2 times the quantity a sub n minus 1, which is the previous term, right? And then plus 3 times the quantity a sub n minus 2, which means this formula right here is not only using the previous term to get the next term, but it's also using the term before that to get the next term. So it needs two of the previous terms to be able to get your new value. And therefore a sub 3, in this case, a sub 3 will equal what? So I'm going to give you like 10 seconds right now to think about that, what a sub 3 will equal. Or stop the video and see if you can get that, because this is kind of a cool one. Again, it uses two different things to determine what's going to happen next. Okay, kind of like maybe you're like, hey, Mom, can I go out to the movies Friday night? I know, crazy if you're still watching during the COVID time, because nobody gets to go to the movies right now because we're all home sheltering in place, right? But if this is a future year, awesome. Maybe, hopefully, you get to go to the movies again. So this is a sub 3 equals what? And hopefully, again, you're ready to go. So a sub 3 equals 2 times the previous term. So 2 times 11 is 22, right? Plus 3 times the term before that. 3 times 4 is 12. So 22 and 12 is 34. Yay, hopefully you got that. So again, that's just another example of recursive formula. It doesn't have anything to do with the next problem. I believe you can do this problem on your own. I believe that you can do this problem on your own. It's just the same as this, except now it's in story problem format. So it gives you an example of that. This one says, here's a recursive formula, right? And it says, hey, can you go the other direction? Can you take that recursive formula and make it an explicit formula? Well, this is what I'm going to do. I'm going to go ahead and write the first term, 13. And then I'm going to try and write the next one. Well, it says the next term is 4 times the previous term. So 13 and then 4 times the previous term would be 52. And then 4 times the previous term would be 208. And that's how that sequence would generate. So how do I write a explicit formula for it? Well, explicit formula, a sub n, looks like, how does it change, right? Does it change? Oh, it looks like it's a multiple of 4. So if it's a multiple of 4 each time, that means that it is geometric, right? Geometric. And I'm going to get, geometric formula is this, right? A sub 1 times r to the n minus 1 power. So a sub n is equal to a sub 1, that's 13, times the rate is 4 in this case, raised to the n minus 1 power. So there we go, there's an explicit formula. This one happens to be geometric, and I knew it was geometric because it goes up by multiplication. It would be arithmetic if it went up by addition or subtraction. Okay, so there you go, that takes you to 49. And I believe that 49, you should be able to follow that one off. Please, if you can, draw a picture. Draw a picture of that one from the stuff. Again, remember, please take your time. Pause the video anytime you need to, watch some other stuff, and you can get through this. So go ahead and try that one on your own. 55 says, identify a real-life situation which you can represent with a recursive rule that does not approach a limit. So a limit, again, like we said before, is something that's going to stop. So Let's try one of these things. It says you have saved 125 baseball cards. Each month you sell 20% of your cards and use the money to buy 50 more cards. So that one's showing you that you're going to sell 20% of that, and but you're going to use that money to help you buy 50 more cards. Okay, so think about how that generates out as a sequence or as a pattern. And this one, you have saved $100 for vacation. Each week you save $5 more. So, okay, that one's 100, then 105, then 110, and so on down the line. See if you can write a recursive rule for that. This one, the retail value of a used car is $8,000. Each year its retail value decreases by 37%. Write out that sequence. Generated that way. This one, the population of a country is 2,500,000 people. Each year the population decreases by 1.3%. Immigration adds 22,000 people. Put that one out. And what it's saying is one of these things does not approach a limit. So you pick the one. Think of it this way: which one is not like the other ones based on how your stuff goes, and then put that one in there. Okay. And that is number 55. Look at that. Do you see that? That is blank. So I will tell you this. I hope that these videos have helped. I hope that you've put in the time to be able to do that. I apologize. I'm going to show you my face right now. Just kind of leaning on it on the side when I was doing those problems and going through it. So this is Mr. Bells. This is spring of 2020 when all of us are stuck in our homes and our houses after school is canceled from the COVID-19 pandemic. I'm hoping you have benefited from these Data B1s and that you take this and you get some credit for it. I'm also thanking you if you're watching this, that you took the time and put the effort in to be able to get credit for this class. And I really hope that come fall, I'll see you in a regular classroom, see you around the school, and that life gets a little bit back to normal. Take care of yourself and take care of your family. We'll talk to you later. Bye now.